Hello, my name is Allison DeLong, and today we'll be discussing how much we know about outer space versus our own ocean. Here are the topics we'll be discussing. We are living on an undiscovered planet with unknown creatures and uncharted seafloors. The planet we're sitting on right now goes to depths possibly unknown still. Let's talk about our planet Earth. Surveying the ocean floor first started in 1807, and it was believed we were lifeless below 549 meters. But in 1968, it was discovered that we actually have life even lower than 4,000 meters. In 1934 was our first manned exploration using a bathysphere, pictured right there. And then also in 1943, we created the aqua lung, which forever changed human interaction with the sea. 1955 is when we discovered magnetic strips along the seafloor, which is key elements in tectonic plate theory. That same year, we developed the Deep Tow System, which is a forerunner in unmanned oceanographic systems. 1992 is when Poseidon, the satellite mapping was first created, and that led the way to nationwide mapping. It wasn't until 2010 we started the census for marine life, and in 2012 was the first solo mission to our known deepest point in our ocean, which is also known as Challenger Deep. We still have 80% unexplored. Part of the reason for that is the seafloor is actually not just a flat land. It has many different canyons and ridges and crevices, making it very hard to explore. According to Robert D. Ballard, the director of Center for Ocean Exploration, we've successfully explored 40,000 square feet, which is only a drop in the bucket of what is left to explore. Here is an image showing generally what we've explored and what we've discovered. As you can see, there's different ridges and plateaus and trenches, but it still is only a very general image of what is left to discover. Now let's talk about space. 1957 was the first space exploration advancement, the launch of the first satellite. And that paved the way for the great space race between America and Russia to see who could get the first man on the moon. And then since then, we have gone on to different planets. Mars was mainly first gotten to in 1970. 1979 is when Voyager 1 and 2 probes were first able to take pictures of Jupiter, and we've only gone farther since then. 2006, we brought back dust collected from a comet, so we're starting to bring back samples as we explore. We have then gone all the way through all 9 of our known planets in our solar system, all the way to Pluto. And in 2012, that same probe, the Voyager 1 probe, has entered interstellar space, which is actually outside of our solar system. And then one major advancement in 2019 was the first germination of seeds outside of Earth's atmosphere, which led to food growth on the International Space System. In this image, you can see the different pathways. Those are actually space explorations, both successful and unsuccessful. And as you can see, we've gone all the way out to Pluto, way up here. And then this image down here shows a scale of how far the Voyager probe and also the Pioneer probe have gotten into interstellar space. According to Jack Single, which is a physics professor at the University of Richmond, these probes are traveling at their fastest speeds of 16,000 and 32,000 miles per hour to continue to exit our solar system. So comparing what we know about both explorations. We know less about 71% of our landscape than we do about the far side of the moon. Current images of the seafloor are similar in resolution to pictures we have of way farther places of Mars and Venus. We also have confirmed the presence of ice on the moon and Mars. And we've just gone really far in our space exploration. Have we even reached the true bottom of our own planet yet? Showing the benefit of our exploration. Sea exploration has environmental benefits. We can see the changes of the environment. You can see the future conditions it can lead to. Deep sea ecosystems have led to medical advancements as well as food and energy sources. Studying the tectonic plates have allowed us to predict earthquakes and tsunamis and other disasters. And this need to explore ocean floor has led to many advancements as well as space exploration. Space exploration has led to medical advancements. With the increase of humans wanting to go out of Earth into outer space, we need medical advancements, so the astronauts don't lose bone and muscle mass. Also, the food and farming techniques have increased, like I said before, with the seed germination, and that can also help with creating more food on our Earth. Having satellites outside the Earth in the atmosphere can help predict asteroid and other breaches of our atmosphere. We are running out of our resources. Going into space can get more of those resources and even new substances. And according to Mary Wojtek, director of NASA's astrobiology program, we have similar goals in both exploring the ocean and space, and it is very important to understand them both. If we understand our own ocean, we can perhaps even understand other planets' oceans. In conclusion, we have learned a bunch about both explorations. The ocean, there's just so much more to explore, and the outer space is just so vast, we barely scratched the surface on exploring both of these aspects. There's many benefits to exploring both the ocean and the outer space. And think about where we'd be today if man had never even thought to explore the ocean. Would we even be sitting here listening to this speech right now? Here are my resources, and thank you so much.